Okay, let's talk vectors. I made this interesting set of code just in order to mess with vectors, and this is not it. This is a video of nothing. The same thing that's on the screen. But either way, I made this video to talk about vectors. I want to start this video with talking about capacity methods, and then we're going to break down other methods as we go. But I do want to mention to you that that we need to talk about what vectors are. We've discussed arrays before. A vector is built on an array, but it allows us to do things like resize it. So you know an array, the size is immutable. On a vector, the size can be changed. We can push to the back of the vector and it will change the size. So to establish a vector, we just actually call the vector. And in this case, I create a vector and I'm going to use an initialize vector call that I've developed just to build a vector based on how big I want it to be. And we're working with an int vector here. So I want to show you what that looks like. The initialized vector, and also I have a lot of errors down here. I'm going to clear that out because this is not relevant to us. All right, so initialized vector is down here. This initialized vector, we're using srand to seed our random function, and then we're pushing back random to the vector. So we're pulling in values between between 0 and 99. So if you wanted to push back a value of 1 to 100, you would just include +1 at the end of this. It would look like +1. All right, and then we're adding that back to the vector. Okay, so the idea, if y'all don't remember the random function pulls from a standard list basically in C++, but that we could seed random by passing in a time function. So to do that, I am using, actually that works. It's native to C++. I was thinking of something else. So basically we have srand, it seeds the random function with the current time. It's always going to give us a different set of values once we plug this in. And then I'm just printing the vector and I'm returning the int vector once we finish that. And that of course builds a vector and it pushes it back to memory, and we're assigning that to my vector. So I don't actually anymore need this call, this print my vector, because it's in the initialize vector call. So let's go ahead and run this. And we'll talk about the sum of the vector, just to talk about how we can traverse it and the algorithmic complexity of a traversal. So let's go ahead and run this. So this is G++, and I'm going to G++ vector play, but I'm going to go and put this script and all the other scripts we work with regarding vectors on the blackboard. So G++ vector play, and some vector was not found in this scope because guess what I forgot to do? This is because I often code in Java, but I forgot to put this at the top. So we're going to take this, and the reason I made vector a long, oh, I see what I did. The reason I made sum vector a long is because it may produce a big value depending on what we're summing. So I wanted to make that long just in case. So let's do that, and let's try to get this fixed. And I do want to talk about the sum method in a second. Did not mean to make this many errors in a video, but here we are. Return sum vector. There we go. Okay. Let's see if this will work. Let's control S this. All right. There it goes. Okay, clear this, and we're going to go and run this with our normal call to a.out. And what you will get is this. We can see the vector, which is 12, 22, 48, 12, 27, 85, 86, 2, 43, 92, 80, 67, 40, 30, 89, 37, 86, 3, 41, 39. And we have that summed as 941. All right, so that's our initialized vector. It's pushing back a random set of values. If I run this again, you will see a different set of values, a different set of values, a different set of values. So we always see these random values happening. If I run it really fast, then time is the same, and you'll get the same actual array, or the same vector, I should say. But generally speaking, when I run this, I'm going to get a random set of values. See how fast I can say there. All right, man, I'm clearing it now. Okay, hold on. You can see it's as long as it's the same time, it generates the same list. But let's talk about this sum vector real quick. So what I'm doing here in main is I'm initializing the vector, I'm creating the vector, and then I'm summing the vector. Just for fun, I'm going to show you what I did with sum vector. Sum vector is a recursive algorithm, and what it's doing is it's passing in the current sum and the current vector, and it's if the vector is empty, it's just returning the sum. Otherwise, it's adding to whatever we get. It's adding the back of the vector, and then it's popping the back off. We're going to talk about these methods shortly, but just be aware that I created a random recursive summing method or summing function just to show you guys that we could use recursion for lots of functions you don't often think about. So let's talk about capacity methods with vectors. So we know how to build a vector. Let's talk about capacity methods. So I'm going to go ahead and take these out, and I'm going to call my capacity methods for my vector. All right. So this is pretty much where I want to start. So we have a blank vector now. We're not calling an initialized vector. We have a blank vector, and we can find out the initial size of the vector by calling size, the max size of the vector, by seeing how big it could be, and we can set the capacity to a certain value by using the reserve function, and then we can find out the capacity by just calling capacity, and then we can resize with a new size, and we can ask if the vector is empty, right? And of course here we see that nice ternary operator, the conditional operator, that is the vector empty? Yes. If it's yes, yes or no. And also we can shrink to fit, which is shrinking to fit the vector to a certain size. So these are capacity methods. We have basically a blank vector right now. So let's see what that looks like when we run these capacity methods. All right, so we're just going to, there it is. Capacity methods was not declared. What that means is that we also don't have this at the top, and that makes sense because I just built this before I started the video without heading this up. All right, so we're going to put the capacity at the top. All right, cool. And then I'm going to save this and compile it, and it should not have any compile errors at this point. All right, vector play and a.out. Okay, so initially when we created the vector, it has 0 elements. The max possible size of this vector means that it could be a big value. I'm not going to try to read that value. You could host a lot of elements. So we're going to resize that space, and you can see right here, we're going to resize it to 10, right? And then we're asking how many elements it can hold, and it's 10. We can that's reserving it to 10, so we're reserving 10 spaces for it. Now the capacity of it is 10, right? We can resize it to 5, and then when I call the size, it calls 5. Then I can ask if the vector is empty, and the vector is no longer empty because we've resized it. Your question might be then, what does it look like? Well, just for fun, because we've not assigned any values, let's go ahead and print the vector at this stage in the game. If I could type. Wow. If I could type. Print vector, my vector. And so there it goes. All right, so once I print this vector out, you'll see it. And I will just go ahead and say, we'll do this. Say this, these are the elements of the current vector. There we go. All right, and let's go ahead and save this and run this again. At least we'll know what we're looking at, right? And of course you see 0, 0, 0, 0, 0 because nothing's been assigned yet. We're going to go ahead and do that again before we resize it to 5. So let's go ahead and run this when we set the capacity, right? So y'all can see this working. All right. All right, so these are the elements of the current vector. You can see that when we set the capacity to 10, right, it went ahead and reserved those 10 elements, but they're not sized yet until we actually make it contain 5 elements, right? And then, of course, we can shrink the container, the capacity of the container, to fit just that size of 5, right? And I do want to do one more thing just to see that. I want to do the max size again, just so we can look at that. I think we'll get the same thing, right? But we just want to look at that max size at the very end here. And these are the kind of things I play with the language to kind of understand exactly what's happening, right? And so the max size doesn't change, but the capacity did change, and you can see that capacity changing there. All right. So these are basically the methods that we've learned here, just so you're aware. Specifically the capacity, we've learned size, the max size, how to reserve a certain number of elements, how to find out what the capacity actually is, right? We found out how to resize the vector, and what that does is it resizes it. It'll delete any elements beyond the fifth or index 4, and then how to call the size with myVector.size, how to find out if the vector is empty, and then how to shrink to fit the vector. So those are some of the container methods, and we will stop the video here.